Ever looked up at a rocket launch and thought, how on earth does that thing actually lift off? It's a question that's fascinated people for generations, and the answer is both simpler and more mind-blowing than you might expect. Today, I'm breaking it down. Rocket science, the easy way. We'll peel back the layers and see how rockets really work, using everyday ideas and a dash of imagination. Okay, here's the secret. Rockets work thanks to a simple law of physics. It's not just for scientists in lab coats. It's a rule that affects everything, from bouncing balls to, yes, giant rockets. Newton's third law says, for every action, there's an equal and opposite reaction. This law is the foundation of how rockets move, and it's as true in your living room as it is in outer space. In rocket speak, when a rocket blasts hot gas downward, it gets pushed upward. That's the action and the reaction, working together. The force of the gas shooting out pushes the rocket in the opposite direction, lifting it off the ground. But how does the rocket make that huge blast? What's really going on inside that powerful engine to create such an incredible force? It's all about fuel and something called an oxidizer. These two ingredients are the heart of every rocket engine, and they work together to unleash a massive amount of energy. On Earth, we burn things using oxygen from the air. That's why a campfire needs air to keep burning. Take away the oxygen, and the fire goes out. In space, there's no air, so rockets carry their own oxidizer. This lets them burn fuel and create thrust, even in the vacuum of space where there's no atmosphere at all. When the fuel and oxidizer mix inside the rocket's combustion chamber, they ignite. This controlled explosion creates a burst of energy that's harnessed to propel the rocket. Boom! Super hot, high-pressure gas is created, and it rushes out of the nozzle at the bottom of the rocket. This jet of gas is what gives the rocket its incredible push skyward. Now, the nozzle isn't just a fancy tube. It's a carefully engineered part that makes all the difference in how efficiently the rocket can fly. It's shaped to squeeze the gas and shoot it out as fast as possible. The nozzle's design turns the energy of the burning fuel into a focused, high-speed blast. The faster the gas goes, the more thrust the rocket gets. And thrust is just a fancy word for the force that pushes the rocket up. This is what lets rockets break free from gravity's grip. More fuel burned, faster gas out, more power. That's why rockets need so much fuel, to generate enough thrust to escape Earth's pull. But here's a wild fact. Most of a rocket's weight at launch is just fuel. In fact, up to 90% of the rocket's mass can be fuel alone. To solve this, engineers use staging. This clever trick helps rockets go farther and faster without carrying unnecessary weight. Imagine a rocket made of stacked sections. Each section or stage has its own engines and fuel tanks, ready to do its part of the journey. When the first section uses up its fuel, it drops away, making the rocket lighter. This means the next stage doesn't have to carry empty tanks, so it can accelerate even more. The next section fires up and so on, until only the part that needs to reach space is left. This step-by-step process is what lets rockets reach incredible speeds and heights. Once it's up there, the rocket can drop satellites, carry cargo, or even send astronauts into orbit. Rockets are the ultimate delivery trucks for space. And guess what? In space, rockets still work. They don't need air to push against, just their own fuel and oxidizer. Even without air, Newton's third law does its thing. Every puff of gas from a thruster sends the rocket or spacecraft moving in the opposite direction. By firing little thrusters, rockets turn or speed up, all using the same action-reaction trick. This is how satellites adjust their orbits and how astronauts steer their spacecraft. So next time you see a rocket launch, you'll know. It's not magic. It's just science, some seriously smart engineering, and a whole lot of fuel. Every launch is a triumph of human curiosity and creativity, turning simple physics into something spectacular. If you found this breakdown helpful, hit like and subscribe, and keep your curiosity rocketing sky high. There's a whole universe of science out there, just waiting to be explored.